All right, so we're continuing on in section 14 here. We looked at 14-100 tap conductors. Now we're going to look at 14-102 ground fault protection. Subrule 1. Ground fault protection shall be provided to de-energize all normally ungrounded conductors of a faulted circuit that are downstream from the point or points marked with an asterisk in diagram 3 in the event of a ground fault in those conductors as follows. A. For circuits of solidly grounded systems rated more than 150 volts to ground, less than 750 volts phase to phase, and 1,000 amps or more. So A would apply to systems like 277 480 and 347 600 volt. B, for circuits of solidly grounded systems rated 150 volts or less to ground and 2,000 amps or more. So 12208, 12240, etc. Subrule 2. Except as permitted by Subrule 8, the maximum setting of a ground fault protection shall be 1200 amps and the maximum time delay shall be 1 second for ground fault currents equal to or greater than 3000 amps. Subrule 3. The ampere rating of circuits referred to in Subrule 1 shall be considered to be A. The rating of the largest fuse that can be installed in a fusible disconnect. So 200 amp switch, 200 amp fuse. B. The highest trip setting for which the actual overcurrent device installed in a circuit breaker is rated or can be adjusted to. Some of these larger circuit breakers, they're adjustable. They have a large frame size and then you can install plugs that change the setting. Or C, the ampacity of the main conductor feeding the devices located at points marked with an asterisk in item 2 of diagram 3 in the case where no main disconnecting device is provided. Subrule 4. This protection shall be provided by A. An overcurrent device that incorporates ground fault protection. B. A ground fault tripping system consisting of a sensor, relay, an auxiliary tripping mechanism, or other means. So when we get into the larger ampacities, 2,000 amps, 5,000 amps, we can't have a solid, we have to interrupt this fault current pretty quick. 5, the sensor referred to in Subrule 4 shall be A. Sensors that vectorially totalize the currents in all conductors of the circuit, including the grounded circuit conductor where one is provided, but excluding any current flowing in the ground fault return current path. B. Sensors that sense ground fault current flowing from the fault to the supply end of the system through the ground fault return path. Or C. A combination of these two types of sensors. So you guys, Subrule 5, the engineers do these calculations on these trip settings. As a journeyman electrician, you're not going to be doing that. 6. The sensors referred to in Subrule 5A shall be permitted to be installed at any point between the supply transformer and the downstream side of the disconnecting means marked with an asterisk in diagram 3. But if located downstream from this disconnecting means, the sensor shall be placed as close as practicable to the load terminals. 7. The sensors referred to in Subrule 5B shall be located on each connection between neutral and ground. However, where the neutral is grounded, both at the supply transformer and at the switching center, the sensor at the transformer shall not be required, provided that the maximum pickup setting of the ground fault relay does not exceed 1,000 amps. 8. In ground fault schemes where 2 or more protective devices in series are used for ground fault coordination, the upstream protective device settings shall be permitted to exceed those specified in Subrule 2 where necessary to obtain the desired coordination provided that the final downstream ground fault protective device in each circuit required to be protected conforms with the requirements of subrule 2. So now students, you are not going to do every little subrule here. In ground fault protection, you need to understand subrules 1 and 2 and the settings here in 3 and the ability to, we'll go take a look at diagram 3. These other rules down here towards the bottom, these later subrules, are design rules for engineers when they're designing systems, all right? So although you might get a question in there, mostly you're going to be looking at subrules 1 and 2, all right? So let's go take a peek at diagram 3. And it gives us these ultimate point of conductor de-energization. All right? So here's the asterisk they're talking about, and they were referencing these different pictures. So what does coordination mean? It means this. If there's a fault here, for example, where my mouse is pointing, we do not want this circuit breaker here to trip. We want the one closest to the fault. So the whole idea is in a plant, you want the branch circuit over current device to trip and take the branch circuit offline and not the main fuse. That's the basic concept of coordination for you to understand. All right. So going back to the rule here. Let's just be aware that you guys should highlight subrules 1 and the part about more than 150 volts to ground, and in subrule 2, rated 150 volts less to ground. You're looking at these values, these current values. Here it's 1,000 amps and here 2,000 amps. These are kind of the questions you get. Like I said, these other later subrules, they're getting into what the engineers are going to use when they're designing the system. So that's enough in 14.102, and in the next lesson we're going to do 14.104. All right, see you then.